Well, I'm so grateful that we're sitting down, and you're one of my favorite people, you and Shar. So this is
And
fun.
vice versa, by the way.
Fun to do this.
I'll start with being born in Punxsutawney, Pennsylvania. No laughs in the audience, please. No repeats, but it was Punxsutawney. My grandparents and my father were coal miners in the Punxsutawney there. I lived there for the first 5 years of my life, and then my father moved to another coal mining town called Ernest, Pennsylvania. And this was a real eye-opener for me, although only 5, that all the houses were the same. They were company houses. There was a company store, a company post office. The company supported the school, the elementary school there. So Carrie reminded me of a bell. This is a bell from my first grade. It was a parochial school. A nun would ring the bell every morning when school would start, and we discovered that a few months ago when we were, my mother had passed away recently, and we were cleaning out her house, and she had that there. So it rings. I ring the bell now for our group meetings. I get down and lived in Ernest, Pennsylvania for 5 years. So now I'm 10 years old, and then my father worked in the coal mines there, as did my 2 uncles who lived in that small town, and my grandfather on my mother's side. So we come from a coal mining family, and in Appalachia, of course, and at times one gets the general idea that you know, you're poor and you're underprivileged. I never felt that. There was love in our family, and there was always food, and my mother worked part-time as an accountant. We lived and had fun and went to school and did things, but my parents absolutely said that my brother and I would go to college. Mm-hmm. And this would be the same story about my wife, Shar. She was born in another small coal mining town called Sagamore, Pennsylvania. And her parents said to her and her brother, they're going to some college, because we were the first in our family. I was the first in my family to go, and Shar was the first in her family. And their parents did not go, or grandparents. No one else had gone to college. So that was a big, big, big issue.
You know, I come from a coal mining family too. And my dad always said, you should talk about how long and hard those days were. Your great-grandfather and grandfather went down in the mine before the sun was up, and they came out after sundown, and then they did the chores on the farm, and that was 6 days, sometimes 7 days a week. And actually, my son's namesake, middle name, Oliver, is the great-grandfather who died in a slate mine collapse.
Oh,
and
wow.
he was brought out, and workers were brought in the next
Yeah,
day. It was a different time.
That's absolutely true.
But my dad also says he doesn't remember. He said we were poor, but we didn't feel poor.
No.
And he talks about what you did, the love in the family. And so I'm really curious. You're so successful, and you're so giving. And I think often our stories are shaped by the habits and the mindsets of people 200 or 300 years before us in our family. So could you talk just a little bit more about those coal mining roots and how you think that's carried with you in ways that might be different from others you've experienced from other places?
You know, each day I'd wake up and go to school, and my father would walk me. He'd be walking to the coal mines, so it was close enough that he would walk, and the school was on the way between the homes and the actual mines was the school. So I would walk with him every day, and my 2 uncles, if they were on the same shift. But my grandfather would tell the stories of working 12 hours, 16 hours in what's called low coal. So if you go into mines, I've never been in ones, but you could have high coal where people could stand up. But some of the miners go in coal that's only 3 foot high. I mean the channel, the tunnel's 3 feet, and they're working with their tools in that for 12 hours. Water, it's just horrible to hear the stories, but they did it. And I used to be intrigued and impressed that on Sundays, every Sunday they would go to church. Of course, in our family, we go to church with them. And they would wear suits, nice suits. And after they came home, they would have a nice meal. And all day they would have their white shirts. So I learned from them to be pragmatic and driven to accomplish something. Their accomplishment was to support their family. So I was very, very impressed with that. I can remember that the coal that came out of the mines went onto a train and exited Ernest, Pennsylvania, and probably went to Pittsburgh. I'm not sure of that, but I remember that, you know, when coal was on the big train carts, as it's going, some of the coal would fall off. And my grandfather would send his grandchildren, me, my brother, and 2 other cousins who lived in Ernest, PA, with coal buckets down to the railroad tracks, unsupervised with parents, to pick coal that fell off of the coal cars to come and then put in their house's coal bin. So they were thrifty, there's no doubt about that. But again, I was never deprived of anything. Good meals. But it was in retrospect, it was a lesson of how they, I'll use the term struggled. I don't mean that in a sense of struggling for life, but how they worked so hard and they were so thrifty to be able to have their families accomplish something.
A lot of the struggle, I think, is what builds the character. And I know from your giving that faith has been a continual part of your values. And I hear it now, thinking about them. You know, they're got to be tired after 6 days of work, putting on the suit and taking the family to church. And I don't know if there's anything around, you know.
No, I'm deeply faithful. I believe in a supreme being of some sort. You call it God. You may call it Mother Nature. I'm not sure what, but I'm a biologist, and biologists are supposed to think that there was a primordial soup and some rocks and water, and enough chemicals came together with a strike of lightning or some energy source to start life. Well, that's a big, come on. That can't happen. If there was this primordial soup where RNA, where nucleotides came together, okay, I give that to you. That's probably possible. Why would they want to replicate? Tell me that. Why would they want to replicate? And then if they do start replicating, come on, we've been in existence in the universe for 13.8 billion years. I think there has to be some direction to this whole thing. So I don't know if you want to keep this. So I believe in a higher order. One of the things that you asked me, do I remember my first experiment? I'm a scientist now, supposedly. No, I don't remember it because my parents, again, wanted us to go to college. And I did pretty good in high school in general studies, but I really liked history. I liked the Civil War history, and I liked to learn about the presidents. So my father, when we would be watching football on Sunday in his white shirt, and my brother and I had sweatshirts and blue jeans on, during the commercials, he would say, we're going to learn something. We're just not going to sit here and watch football. So during the commercials, first he taught us all the presidents of the United States. And to this day, I know them, and I can say them in 1 minute. Washington, Adams, Jefferson, Madison, Monroe, John Quincy Adams, Jackson, Van Buren, Harrison, Tyler, Polk, Taylor, Fillmore, Pierce, Buchanan. That was commercials. So after probably a month every Sunday doing that and memorizing them.
I love it. It's a great idea.
What else do you want? What else in history? Well, we had to learn all the states and all the capitals, so I know all those and retained them. What else do you want to know? It's another month later, and this is every year, so he'd test us. And the Gettysburg Address, 77 years ago, our fathers brought forth on this continent. So I still remember that stuff. And I don't know if that helped train anything in the brain as to how to remember things, but knock on wood, memory is still pretty good, although I get forgetful sometimes. So I go to college, so that's during junior high, high school, and whenever there was a commercial, we would talk something about history or geography. Go to college, I go to enter Indiana University of Pennsylvania. Indiana, Pennsylvania is in Appalachia, a coal mining district, very similar to Athens. And my major was history. So my first history course, I'm all excited. I knew the Gettysburg Address, all the presidents, all the states, the preamble to the Constitution. I knew all that. And here it was the geopolitical aspects of American history from 1960 to, so it was something that was nothing that I learned. And I said, no, this isn't going to be good for me. So luckily I took a biology course, an intro to biology, which was an elective that I had to take. And here's what's very important in my life. When I took this biology course, part of it was developmental biology. And the instructor, and I can't even remember who it was, said, look folks, at one time you were an egg in your mother's belly. A sperm came in and fertilized that egg, and it was one cell. And 9 months later, it was 25 trillion cells. Think about that. I'm still impressed by that. One cell to 25 trillion in 270 days, 99 months. And then from birth to when puberty, to you become an adult, there's another 10 to 15 trillion cells involved in the growth of that infant. Everyone in the world should want to study that aspect of biology. How in the world does one cell go to 25 trillion in 270 days? I still don't get it. And in that 200 trillion cells, there's eyes, there's skin, there's heart, there's pancreas, there's toes, hair. You know, so the differentiation of those cells as they're dividing at this incredible rate just still absolutely fascinates me. That's when I wanted to become a scientist. I said, I want to study how that works. And so I changed, it was in college. I changed from a history major to a biology major. And the rest is, I'm still fascinated. I hope you see my passion, and this isn't an act. I'm still committed to trying to understand how one cell with all the genetic information can give rise to now 40 trillion cells that are all different types of cells doing different things. Unbelievable.
Yeah. Well, you know, there's a lot of science now on the benefits of awe, of being inspired and seeing something as truly awesome. And that you just described
that was
it,
my
right?
that was my eureka moment. It's
been a thread of your life, and I'm
100%.
in awe and all of your story, right? Did you ever think that you would invent a drug that would save, I don't know how many lives by now?
I don't know exactly the number, but in the thousands.
Tell us the story, and tell us what it's like to meet the families.
Yeah, so I graduated from Indiana University, Pennsylvania. I stayed there 4 years, and then I got a master's another 3 years with a very, very good professor. His name was Dr. Richard Hartline. He was a biochemist. So he then, when you want to study one cell going to 30 trillion, you have to narrow it down a little bit. And so he was studying one metabolic pathway in bacteria, and he really taught me and my other colleagues who trained under him how to do science, how to set up a question, a hypothesis, and then how to do experiments to test to see if that idea is right or wrong. And I ended up getting 2 very good scientific papers from that master's degree there. And just by serendipity, he had taken 3 graduate students to West Virginia University to hear a seminar of a professor from Texas talking about cancer cells and how the genetic material in the cell goes awry to allow these cells to grow uncontrollably. And I wanted to learn, he wanted to learn about it, so he took us. And the professor who gave the seminar there at WVU was Ralph Arlinghouse from MD Anderson Hospital. It's a big cancer hospital in Texas, the biggest in the world, I believe, and the best. Anyway, he talked about viruses that cause cancer. And I asked him during the seminar a couple questions, so afterwards he wanted to meet me. And so with my advisor, my master's advisor, Dr. Hartline, we met Dr. Arlinghouse, and after the discussion, I was so infatuated. He says, what are you going to do after you get your master's? I said, well, I'm not sure yet. He said, why don't you go to get a PhD and come work for me? I said, what? I said, yes. So I said yes right away.
In that instant.
Then I said yes, but then you had to have the qualifications and, do all the preliminary test, which luckily I passed, and I went to Houston, Texas to study viruses that cause cancer. So that took 4.5 years in Houston, which was great, made a lot of good friends, a lot of good laboratory companions, but there it was big time science. The lab had 20 people, 4 or 5 graduate students, a few technicians, but the postdoctoral fellows, these are people that have their PhD but now are learning how to do research on their own. And I was assigned to 2 different ones that would really teach me. I did well, and I loved it. I absolutely loved it. But again, this was all trying to understand how DNA works. Viruses have nucleic acids, or DNA or RNA, and how it can give an organism or a virus its characteristics. That basically goes back to the characteristics of one cell giving rise to this 25 trillion. Excuse me. So then I did well there, and I did become a retrovirologist. These are RNA tumor viruses, cause tumors in mice, rats, cats, dogs, all vertebrates, humans. So I went on to do a postdoctoral fellow. Again, this is learning after you get a PhD, really how to do things on your own, how to write grants and so forth. So I went to the Roche Institute of Molecular Biology in Nutley, New Jersey. It's sponsored by the company Hoffman LaRoche, and it was the best absolute place I've ever been. The company supported all the research that went on there. It could be basic research. It wasn't company oriented. There was a Nobel Prize winner, Surveya Ochoa, there, who discovered the genetic code, and this is right where I wanted to be, right where I wanted to understand how this stuff works. So I spent 3 years there, and it was absolutely glorious. Did very well, again studying viruses that cause cancer, but now really in the process of being a molecular biologist, understanding how DNA in your cells regulate everything. Mm-hmm. And then I got my first job at Merck & Company in New Jersey. So most of the individuals in my type of science, is molecular biology, will do a postdoc and then go to academia. I did a postdoc, and a few of my colleagues there at Hoffman LaRoche went to pharmaceutical companies, yeah. And mine happened to be Merck & Company in Rahway, New Jersey. And there's, I really learned how to use what we learned about manipulating DNA and to turn that manipulation into the discovery of drug targets or targets for the development of drugs for a given disease. Mine happened to be proliferative diabetic retinopathy, eye disease. And what genes go awry to cause that. So I did well there and was there 5 years, and the president of research, Dr. Ed Skolnick, was a retrovirologist at the National Cancer Institute who went from the NCI to Merck. He was president of research, and he had heard about me, so at meetings he had always, Kopchick, what's the most important thing in drug discovery? I said, I don't know, probably discovering a drug target, and they would say, no, drug discovery and development is potency, potency, potency. I remember that to this day. But I also learned there the power of protecting discoveries via patenting, and that was crucial to the story of Sommervert. Okay, so I did well there. I got a call. Merck wanted their scientists to go out and share their accomplishments via publications or giving talks. They encouraged that. So I got a call one day from a headhunter saying, would you like to come to, here's what I heard, would you like to come to Ohio State University to give a seminar on your work on growth hormone genes? And I said, sure. I said, I'd be glad to. And they said, okay, we'll organize, get you a flight and into Columbus. And I thought, I'm going to the Ohio State University. That's where I thought. So I got into the airport in Columbus, and this is like 1985, and their son is there to talk to Kopchick, and I assumed it was a taxi, and thank you, so we got in. But it wasn't a taxi. We didn't get into anything. We walked to another terminal and got in a small plane. And I'm thinking to myself, my God, this Ohio State University, the Ohio State University, really arrogant to take you with a small plane from the airport to wherever
Right.
we're going. I didn't know it was where in Columbus it was. I said, this is really arrogant.
15 miles.
Come on, yeah. I said, here it was a 20-minute, 30-minute flight to a remote area, Athens, Ohio. And it was in the fall, this time of the year. It was very beautiful looking at it from the sky. And I'm thinking, Ohio State has a branch campus this far away, and as we flew over, we could see all the buildings. I said, wow. I said, they are big. Well, it turns out it was Ohio University, not Ohio State University. And they were looking, the seminar I gave, it was well received, I think, but there was a hidden intention for them inviting me here. They were setting up a biotechnology institute, the Edison Biotechnology Institute, which you're in right now. And they needed someone to help Dr. Tom Wagner, who was the first professor whose research led to the establishment of the Edison Biotechnology Center. They needed a DNA guy, and that was me. And the other good friend who I did a postdoc with at Hoffman LaRoche was Dave Scholl.
Oh.
So Dave and I have been friends since 1980, and he was here. He had graduated. He was a graduate student at Ohio University, and he set up the company that led to diagnostic hybrids. So he was here before me. He came back to his alma mater, and he won't admit it, but I think he had something to do, and Tom Wagner, for inviting me out here. And so in the next 4 or 5 months, they wanted someone to help with this biotech institute, the Edison Biotechnology Institute. They knew something about DNA and how to clone genes and how to manipulate them and so forth, and that was my expertise. So I came, and what is good, how the whole story finally evolves. This Edison Biotechnology Institute, named after Thomas Edison, who worked in Procter & Gamble. And at one time, he had more patents than anyone in the world, I think, or at least the United States. I'm not sure if that's true today. But the state of Ohio had a program, an Edison program, to promote institutes at different universities in science, different types of science. Ours was biotechnology. In Akron, it was material science. So there were 4 or 5 in the state. And the idea was to be affiliated with the university, be a university professor, train students, give talks, write grants. But if you discover anything, think about protecting the intellectual property so that, a patent, in other words, so that perhaps a company could license that patent, or perhaps you could start a small company. It wanted to make jobs within the state of Ohio. Children, growth hormone makes us grow, as the name implies. There are children that are deficient in that. They have mutations in a gene, or the cells in the pituitary gland that produces growth hormone from that gene are disrupted or sick. And they're growth hormone deficient, so the children will be growth hormone deficient, so they're short. And in the 1986, growth hormone coming from the human growth hormone gene was formulated, put in vials, and approved by the FDA for these children who are short. They're growth hormone deficient. That's the good news, and it reconstitutes growth. The bad news is they have to take a shot every day. So if you're diagnosed with that, if a child is diagnosed at 4 years old, they have to take a shot every day until they're 17, 18, 20 years old. No one likes shots that much.
Right.
So our goal was to see if we could create a growth hormone molecule that would be longer half-life. In other words, instead of taking a shot once a day, maybe once a week. Maybe once a month would even be better.
Back to your potency, right?
What?
Back to the potency.
Yeah, exactly. To make it more potent, so you give it less frequently. Very good. Very, very good. So we discovered something that was not, so we were trying to come up with a better growth hormone molecule. We discovered something that was just the opposite. It didn't enhance growth. It didn't do what growth hormone does better, but it actually inhibited growth. Just the opposite of what we set out to do. So back to and then I didn't believe it. We had these mice that, normal-sized mice, you put this gene in that we thought would give really big mice, and we got little mice. And I didn't believe it. I made the student go back and repeat the experiment, which took another year. And yep, it's true. So this taught me one thing: data does not lie. It may not be what you think, but data does not lie. Your interpretation may be wrong. It does not lie. Go with the data if it's true. So we start talking about this and writing publications. No one believed it. There was never a large molecule growth hormone antagonist. In fact, there was no antagonist for anything in your body that was large. There were small molecules, but this was a large molecule. I remember going back to Merck. When I left there, they said, if ever you discover anything, come on back, give us a chance to go with it. I went back there and I knew the head of research, Dr. Skolnick, and I talked with some of the directors and so forth. None of them believed it, and yet they liked me. But they said, nope, can't be, John, you can't do it. So learned a very, very important thing. If you have to have a champion, and you have to believe in the data, and I believed in the data. We had these little mice. People say, well, how do you know you do it? I said, well, we put the gene in. Instead of getting big mice, we get little mice. You tell me how it works. I said, that's it. And then we had the biochemical and hormonal, the endocrinology that went with it. So then was there any, so something completely unexpected. So that's good for patenting. It's novel. It's definitely novel. So we had a relatively easy time patenting that. But what is it used for? You need a use for something. Well, it'd be used for people that have too much growth hormone. And I didn't know too much about that until we made the discovery. These patients, they're called patients with acromegaly. Their pituitary gland produces too much growth hormone. They have a tumor in their pituitary gland that allows it to produce too much growth hormone. And if that mutation in the cells in the pituitary happens to promote too much growth hormone as a child, and if left untreated, they'll become a giant. Andre the Giant is the most well-known of that. Now those people, I could show you slides and so forth, he only lived to be 45 years old. They die prematurely. Too much growth hormone is not good. It's not good. It's involved in cancer, and it can cause diabetes, so it's not a good thing. So could our drug be used for that condition? So we set up a company right here called Census. It wasn't a virtual company, it was a real company that set out to produce and to develop this compound of ours. And it was named pegvisomant. It had some chemical modifications on it called polyethylene glycol, so it's pegvisomant is the drug. And it went through, unbelievably, clinical trials, preclinical trials in 2 animal species to show that it doesn't cause tumors or affect reproduction, or it's allergic, the animals aren't allergic. Then it went through the human clinical trials, the 3 trials, phase 1, 2, and 3, and it worked. And every day, this was a 10-year period, and I just couldn't believe. There were many hurdles that we had to jump, but when it came time to looking at the data in humans, it was turning out very, very, very good. That is, it was working. And in 2003, March, it was approved by the Food and Drug Administration for patients with acromegaly. So a little mouse that we didn't expect, I didn't believe in the beginning, ended up being a compound that is an approved therapeutic for patients with acromegaly.
Now saving lives.
Has
come back and made this a very
And right
strong...
there in that seat where you're sitting, I've had 3 patients, this is before COVID, one of which is a woman from Cleveland who comes on her way with her friends. She goes from Cleveland down to Myrtle Beach. She stopped here every other year, sitting right there, thanking me for her life. That gives me chills right now, and I get choked up every time I think about that. Sitting right looking at you, I said, wow, that's an honor to be able to have a compound that's useful in your life to help you. And she said, no, it did more than helps, it saved my life.
It's amazing. It's amazing. And I can't help but think back to Dave Scholl, who I would probably suspicion had some vision in mind, because Dave is how we met. Dave has a foundation with the Foundation for Appalachian Ohio, and he said, you got to meet my friend John, and to think about now what you have done to set up the future for research here in Appalachian Ohio and at the university. It's just incredible how it's come full circle.
We've wanted, as Dave is a true friend, and by the way, his company that he set up, Diagnostic Hybrids, was a success story.
Absolutely.
Now quite ill, and it's a very, very big success story. What was the question?
Well, I'll ask you the questions that I'm programmed to ask you soon, but I'm so fascinated with this, and you know I'm a 2-time cancer survivor, and you've been so kind through my journey to be somebody I could rely on for perspective.
Yeah.
It sounds, and I know from our discussions, that there's a lot of hope
Yeah,
that you
so
see for cancer with your work.
So when you discover a drug, that's a good thing. You know, I worked at Merck, I told you, 5 years. We probably screened over 1,000 compounds, none of which ended up being a drug for eye disease, for diabetes. 0 for 1,000, maybe it's 0 for 1,500. We came here to work with one molecule and got a drug. So 0 to 1,000 there, 1 for 1 here. So I don't know, there's a lot of serendipity and a lot of luck and a lot of directed luck, if you want to call it that.
Directed luck, I like that.
Yeah, but if you do one, you want to do something else, you know. So we did this, that was approved 20 years ago. So growth hormone promotes cellular growth. Does many things, but it is involved in growth. If you don't have it as a child, you're short. Well, cancer is abnormal cellular growth, so we said, why not? And my training is really as a cancer guy. I told you about leukemia at MD Anderson Hospital, and as a postdoc, viruses that cause cancer. So I was dangerous in the cancer world. I knew enough to be dangerous. So I said, let's try this to see if growth hormone will stimulate certain types of human cancer cells in the laboratory, in the hood back there that I showed you. And if so, would our compound then inhibit growth hormone's effect on this? And sure enough, not every cancer, but 4 of perhaps the first 10 we tested, melanoma, liver, pancreatic, and bile duct or cholangiocarcinoma, it will inhibit their growth. I said, come on. I said, this is too good to realize it. So we published a few of those. And for pancreatic cancer, we've had remarkable results. In other words, you take the cells in culture in a dish, the antagonist or pegvisomant will inhibit its growth. Well, what about in the body? This is in a plate in a laboratory. So you take human cancer cells, you put them into what's called an immunocompromised mouse. They will grow, like for example, pancreatic cells will grow into tumors, and sometimes you'll get metastasis and so forth. So after you can start measuring the tumors with a little caliber, you can then start treating with different things. So you can treat with the typical chemotherapy used for, in this case, pancreatic cancer, or you could treat with our drug in mice, or you can mix the two together. And unbelievably, the typical chemotherapy will reduce the cancer load by about a half. Our drug will reduce it also by about a half. Wow. But that's good. In the cancer, you know that's good. If the size of the tumors don't increase, that's good. But it's not curing it. But if you mix the two together, and let's say our initial experiments was with 8 mice, if you mix the two, our drug with the chemotherapy, you got 4 out of the 8 mice, you couldn't see the tumor. The tumor went away. Now that's spectacular, that kind of stuff.
That makes me teary-eyed.
Yeah, that gives me chills again too. And so that's just being written up. It's going to be submitted for publication probably next week. And then for melanoma, and liver cancer, we got very, very similar types of results. Sometimes cancer-free, but definitely the mixture of the 2 drugs are very, very, very good. And so what's happening is our antagonist is helping the chemotherapy to stay within the cells so that it has more time to kill the cells. That's
what's happening.
Easy way to there's a lot of molecular biology in that, but that's really what's happening.
Well, it mimics fasting, right? I mean, this is a rudimentary understanding of it, but can you speak a little bit?
So my very, very dear friend, Walter Longo, who's really one of the world, if not the world's expert on dietary manipulation as a function of healthy aging. There's a compound that food, in particular protein, will upregulate in your body. It's called IGF-1. There's a compound that growth hormone upregulates and makes you grow. IGF-1, the same thing. So that's important for growth. There's no doubt about it. It's an important growth factor. But later in life, do you really need that? And he found by dietary manipulation, you can lower IGF-1, and that's what our drug does. So you put that into people with acromegaly. They have high IGF-1. This drug lowers it. So two different ways to lower IGF-1. And he found that the dietary manipulation can, in a positive way, reduce cancer, certain types of cancers, just like our drug, certain types of cancers it can actually eliminate. And so he and I are talking, so we're collaborating now, and more than that, we're setting up a company. We set it up, I can't give you the name right now, but the idea is a patient who has a tumor. It's going to be treated. It is treated with chemotherapy and perhaps going for surgery. The idea would be to, before surgery, maybe a month, to put them on a restricted diet that would lower IGF-1. And oncologists just think this, the opposite. They want to really have a lot of energy in it, just the absolute opposite. And then maybe 3 or 4 days before the surgery to to inject them with our drug that would really lower IGF-1. So when that patient goes into surgery, they'll have very, very low levels of IGF-1. And IGF-1 is important for the growth of many types of cancers, many types. So that's the idea.
I just thought that was amazing when I read it, because I had been reading research about if you were in a fasted state with your chemotherapy, it was more impactful, but who can fast all of the time? And there was this fasting mimicking diet, but it's very difficult to ask a cancer patient to follow that.
And it's hard to regulate it at the patient level, because the poor patients, they get hungry, and if they want a milkshake or something, you want them to have it. So a combination of the two, the fasting, which hopefully the patients would do. It's harder actually to convince the oncologist to have the patients fast. But now it's due to Walter giving talks and doing clinical trials. I think the oncology, this cancer community, is coming to understand that diet in a major way can affect the growth of these tumors.
And this is not the first time you've been saying something that people didn't believe.
Yeah, that's why in fact, I sort of like it when we come up with something just the opposite of what we think. I like that because there's been several other occasions where that came up. The little animal we produced, okay? Guess what? It lives longer than normal mice. In fact, the one that doesn't respond to growth hormone at all, it has a mutation in the growth hormone and an inactivating mutation in the growth hormone receptor, so it doesn't respond to growth hormone. It's a very tiny mouse. So what? Well, guess what? It's the longest lived laboratory mouse in the world. And guess what? It gets very, very, very little cancer. Mice normally die from leukemias. These mice don't. And, okay, John, I'd go out and talk about our drug for humans, how we discovered it, and then I say we also take away growth hormone action with our drug or genetically, and you get this small animal that is resistant to cancer, is resistant to diabetes, and it's the longest lived laboratory mouse. We got a prize from not science but nature, the Methuselah Prize. Methuselah was the biblical fellow that supposedly lived 960 years. So there was, I presume, a bunch of elderly people that gave a bunch of money that come up with the longest lived laboratory mouse. And we got the prize. We didn't get any money, but we got the prize.
How long for? How long did your mouse live?
Well, if you want to pay for it and keep them, they could live up to 5 years. But normally they live to 2.5 years. So I give the talk, and the clinician will say, John, that's great. That's great. The drug is great for patients with acromegaly, and you're finding with the mice about inhibiting growth hormone will promote healthy aging and longevity. But what does that have to do with humans? And then I would start stuttering, say, well, no, we really don't know. Until this fellow, Dr. Zvi Lerone, this isn't an advertisement, this is his book, My Way. It's written in Hebrew, so I can't read it. But anyway, he and I are collaborators. So he studies patients now, humans, that have inactivating mutations of the growth hormone receptor. So they're short. They're called Lerone syndrome after him. He's Dr. Lerone syndrome. And guess what? Those patients live longer. Excuse me, let me not say that. They live at least a normal life. They don't die prematurely, but they get zero cancer. Wow. So we wrote a book, Lerone syndrome, from mouse to man. So it's the same gene that's mutated in humans, gives short humans, and mutated in mouse gives little mice. In humans, they don't get cancer, and our mice get very, very, very little cancer. So then that puts us in the cancer space now with our drug.
I love it.
So I didn't know I was going to show you that. But
No, I love it. This is a great conversation. So I want to go to community and philanthropy in a minute, but one more kind of big picture question. You know, I think when I had my first cancer, there were 15 years between the two. And how I got information is I go to prodigy.net and I try to search something and I might get very, very little. 15 years later, I had the same studies, the same information my doctors did, and often I'd read them before they had. You know, when you think about where we are in science and you think forward another 15 or 20 years, you know, what do you see? Are we in a rapid time of change that should give all of us hope? And
yeah, I think so. In terms of cancer, you have to realize there are many different kinds of cancer, and there are many. Every cancer, what's unified, it comes from DNA that's changed, it's mutated. So we know that. And we know for all those genes in our body, 22,000, let's say, that are important for us being who we are. About 1% of those, if they're mutated in the wrong way, can give rise to abnormal cell growth or cancer. So the unifying theme that there's going to be one gene that gives rise to all the different kind of cancers is not the case. Now, there's going to be drugs like ours and other things, other discoveries that will hopefully help. I'm not going to say eradicate a particular type of cancer, but each one's going to have special studies. So you know as well as anyone that what is good chemotherapy for breast cancer may not be good chemotherapy for pancreatic cancer, and so forth. So, but as we go on and as people study this, there will be studies on particular types of cancers where there's going to be major advances. No doubt. No doubt about it. No doubt about it. I don't think there's ever going to be one compound that's going to be used for all different types of cancers.
First off, you've made what an incredible difference to the future of Ohio University and of the Edison Institute, and you've changed the face of that completely. But this isn't the only thing you've done, and I know that you have gone to other places that have shaped your career and your ability to have this opportunity. And in one of those, you've worked on funding fellowships for collaboration. I think it's because you believe that sharing information across teams. So can you talk a little bit about, because you think, you know, for those that are giving money and thinking philanthropically, you know, how did you come to the vision that you've had for that?
Well, it goes back to being a child of Appalachia. We're very fortunate to have gone to college, gone to the university, been both Char and I to now be working at a university, and me being in science to be able to discover a compound that's a drug is just unheard of, and it's just very, very, very humbling. And now with that came the sales. Now, helping the patients is the first thing. Okay. But with that came royalties back to the university, of which the inventors get a part of that. And Char and I decided, look, every bit of that money that comes in, we're going to give back to students at the 3 universities that made this happen. Indiana University of Pennsylvania, the University of Texas at Houston, MD Anderson Hospital, Graduate School of Biomedical Sciences, and here at OU. So we're supporting students at those 3 universities. Now, at Texas, it could be medical students or graduate students. There are 12 supported. At Indiana University of Pennsylvania, they're primarily undergraduate students. And Shar has unique students, we call them, that are they could be unique in any way. They could be perhaps physically disabled of some sort. They could be a minority of some sort. They could be first generation, like she and I was in Appalachia. And there's a special niche of support for those at Indiana University of Pennsylvania, and actually at MD Anderson Hospital too. And here at Ohio University, it's all for graduate students who are studying molecular biology or translational biomedical sciences. That is, taking discoveries from the bench, the laboratory bench, to the patient's bedside. Now, we discovered ours in the laboratory bench. It went into the patients at the bedside before that bench to bedside was even talked about. So we were doing bench to bedside before we knew, it was bench to bedside. But it's to help students. It's student-centric, and every 100% of the money that comes into me for royalties is going out. So that's why, when Dave introduce introduced me to you, or to found the Foundation for Appalachia, Ohio, I said, if Dave's doing it, I got to do it. So.
So the longer I've been doing this work, the more I've come to the importance of investing in people. And it's kind of funny because when I first started, I told my dad, we got to raise money, and he said, money doesn't solve problems, people solve problems. Yep. Just keep focused. You're trying to invest in people, and I think that's really where you've come to, is
there's no doubt about
investing in the future of these young leaders.
And whenever we can, I haven't done this enough, but I'm going to start doing it more. I'm going to, in some place when I give seminars, bring this idea. If you're, as a student, if you feel backward, if you feel in some way that you're not up to the other students in the lab because you're from Appalachia, or for us, for you and me, we're from coal mining, right? You said your parents were coal, yeah.
Oh,
we're from grandparents. They're from coal mining families. I mean, I'm proud of it. I don't think that is anything negative, and I want to stress that to students, that just be proud of what you got and don't be afraid to go with it, whatever it is, whatever you may think your a negative attribute is. I'm not saying it's negative, but they may think it's something negative or something that's not quite up to the fellow students in those classes. Now, if you have a question, ask the question. If you're intrigued by something, and if your heart tells you, if you're passionate about it, go with it. And that's what we hope to convey to these students that are receiving some support.
So you seem like someone just has a lot of happiness, a lot of joy. Anytime we're together, we're laughing, right? You could have said, I'm done. You could have moved into another house. You could have been at the Greenbrier playing golf every day, right? Yeah. Dr. Kopchick. And yet you're here, you're working with students, you're giving your time to the Foundation for Appalachian Ohio to let us share your story. Why is that? What do you feel when you give?
I feel wonderful. We feel wonderful to be able to help, again, primarily students. Yeah. And when you get thank yous is even better. When the student comes back and says, hey, that really helped me. We weren't sure we were able to make tuition and so forth. It's another heart-rending thing. So, yeah, I could have retired a long time ago. What's funny is in the past, I've been here over 35 years, something like that. And in the first 25 years, getting money to support the lab was difficult. Usually it's from the National Institute of Health. And if we got one grant out of 10 to which we applied, that's 10%. That's not good, but for us that was good. Now, I don't know what happened, but right now the last 4 grants we put in, we got. So now I have 4 grants that are 5 years, so I got to stay 5 more years now. So that's one reason we keep going, but I like interacting with students. I went from when I first came here to being their older brothers to 10 years later to being potentially students stay the same age.
Right.
I get older, we get older. So I went from being their older brother, maybe their uncle, to their father, to now their grandfather. But I still like them. I still enjoy it. We have a group of about 20 people, and we have a good time, but I love them all, but I give them tough love and teach them how to do science the way I was taught how to do science.
Yeah. Believe it or not, that resonates. I started in this job at 25, and here I am at 42 with more gray hair, right? And,
no, you don't have gray
hair. Well, I do. That's okay. The data doesn't lie. But you stayed in Athens. You're a vibrant part of our regional community here. Can you talk about what you love about living in Appalachia?
Yeah, I love it, period. And I think one of the most important things is the friendships that one develops within the community. And we met many people here in Athens who have similar backgrounds to Shar and I. And at events where we go now, I'm constantly meeting more. Like I didn't know Jeff Chaddick was from Appalachia. And almost every month you're meeting someone else that is relatively successful or successful or really successful who are from Appalachia and stay here. So I like it. I don't like large cities. I lived outside of New York City for 10 years and it was okay, but I didn't really like it. And I just like its geography. I like the change of the seasons. It's the beauty of the leaves right now, and the friendship is the most important thing.
We are working with a lot of educators, and they're across kindergarten through 12th grade. But as you think about those who are trying to teach science or get kids excited about the opportunities, I mean, what are some of the things that, when you're working with students, have become patterns for you over the years that you believe in?
I think having passion about whatever one is doing, if it's in science, you as an educator who students are following or you're teaching students, you have to have passion and be excited about it to get them excited. And I think it's absolutely crucial. And when I go out and teach, I do teaching. I'm teaching lectures in molecular biology right now. The students know I'm passionate. They know I'm crazy passionate. I mean, really. I pose the same question to them as I pose to you. 1 cell, 9 months, 25 trillion. Tell me how that works. Tell me how that works. Come on, tell me how that really works. And again, I tell them I can't understand why all of you aren't studying that. I think the whole world should be studying that. But they know I'm passionate, and I think that is communicated. So not every student, but some of them get really passionate about what they're doing. And you don't, when I tell them all the time, study something. If you're passionate about something, and you want to devote 8 hours a day for the rest of your life, or really maybe 12 hours a day for the rest of your life, and if you're inclined to do something in the medical field, pursue that. Do something that, if just in case something happens that's fruitful, you may be able to help people.
Right.
So choose a project that, in general, has something to do with medicine, therapeutic targets, diagnostics, whatever, and then really pursue it. And you can't sit behind a desk when you get a job. I tell them, you can't say, I'm going to discover a drug. No. We didn't. I was 0-4000 in Merck. So I didn't come to Ohio University saying we're going to discover a drug, but you have to keep alert that if you do discover something, are there clinical implications or applications for it?
Back to that pragmatic and, in a lot of ways, coal mining background. So you know that I'm a fan of David Brooks, and I know that you've read many of his works. In The Second Mountain, he talks about the commitments that bring joy in life. He talks about faith and family and community and having a vocation. And I feel like what
There
you're
it
talking
is.
about
Yep,
is
that's
the joy that comes from having a vocation. It's a calling. It's more than a job.
Yep.
We've left out a really important part of your life, who's probably my favorite part of your life, who's Shar Kopchick.
Yeah.
And is there anything you'd like to say? Because you
she's
guys
a
are an
good-
amazing team.
We met in Indiana University of Pennsylvania, both from different small towns, and actually we're going back next week. This is humbling, and please don't think I'm arrogant about this, but they're naming a new science building after us, Kopchick Hall.
Gosh.
And they're going to cut the ribbon on next Thursday. So we're going back, and this new building is right between the old science building where I spent 7 years of my life and her dormitory where she lived. So I would walk the path right in front of this new building to on weekends go to a movie or something, go to pick her up. And so we met there, and we've been colleagues and friends as marriage goes for, oh goodness, 40, 45 years
45
or something.
years.
Yeah, so and I know she loves you, as everyone
I
does.
love her. She's
Yeah,
special.
and she's with the fine arts department now, and she's part of her job is to bring in performers that would perform in Memorial Auditorium here at OU for the students, faculty, staff, as well as the community, but also to try to get them to go to the elementary schools to give the children in Appalachia an experience with professional musicians, dancers, and so forth, artists, and so forth. And it's wonderful what she's doing. It's really wonderful. Yeah.
What'd she say when a dinosaur was named after you?
Well, she said probably the same thing. She said something like, "What did you do now?" I have to tell you, we're proud of that. I got a lot of notoriety and so forth from discovering a drug, no doubt about it. And I'm proud of that, and proud of helping patients, proud of the money's coming in as helping students. Very, 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 very proud. We've gotten more notoriety about this dinosaur naming. It was on CNN, the Pittsburgh newspapers, Philadelphia newspapers, radio stations, television interviews. Char was counting them. I think there's 25 different interviews
Oh my goodness.
about the dinosaur, and I had to tell them, I don't do work on dinosaurs. They said, well, why don't you clone a dinosaur growth hormone gene? I said, you know, these dinosaurs aren't around. They're about 40 million years ago or a long time ago. And now people study them in fossils. Fossils are rocks. I said, I don't think I could take DNA out of a rock. We may try it, though. I'm telling you, we may try it. I'd just love to clone a dinosaur growth hormone gene.
You know, you talked about the coal mining history that you know, and that's really a history across Appalachian Ohio. And not only was wealth extracted, but it really extracted our opportunity to create philanthropy. And so 25 years ago, some incredible founders started the Foundation for Appalachian Ohio. And in a very unusual way, partnering with government, not with money. And so their first act probably should have been a fundraising campaign, but they looked around and they said, we've been through so much distress, you know, generational distress, and there is a culture of diminished expectations, and there are children who believe they can't do things simply because of where they're from and what they're hearing in the community about where they're from. And they said, the first thing we're going to do is we're going to create a mindset campaign, and we're going to call it I'm a Child of Appalachia. And what we're going to do is we're going to go find the best of Appalachia and the best people in Appalachia to stand up and say we're proud of where we're from. And the history that we've been through is what's been part of our success. And to be spokespeople for our region and champions for all of us to keep the mindset and the faith of what is possible here in Appalachia, and often, quite honestly, because we're from Appalachia. And so almost every year, there was kind of a year off during the pandemic, but a citizen from our region has received this award. We've mentioned several people. Bob Evans was one of them. A lot of people don't know that that restaurant's actually named after an amazing philanthropist. John Glenn was one of those. Ted Strickland, you mentioned your friend Dave Scholl, Nancy Zimpher, Mike Brooks. There's a long line of incredible people, but it is such an honor for us to present this to you, Dr. John Kopchick, to be a Child of Appalachia for our 2023 honoree, and for us to get to share your story of international significance of changing the face of science and cancer care and so much.
Well,
thank you.
Thank you. This is awesome. It's beautiful. Plus, it's a very humbling honor. So I am absolutely proud of this. This is going to be in this office or in the wall there. It's one of the nicest things and the most honorable things I've received. And so I just thank you very, very, very much.
Oh, thank you.